Welcome to GC Engineering and Technical Drawing. Today we'll be drawing a shaft hanger casting using the principle of tangency. So the first thing we do is that we'll draw a horizontal line. From our diagram, we have first major horizontal line and then a vertical line. So we'll be drawing a horizontal line first. Drawing a vertical line. Now you can see that they intersect at a point. We'll call this point. Let me just call this point 0. Now from our diagram, we'll locate first. There are 3 points on our vertical line over here. This is 1, 2, and 3. So they say this is 5 millimeter, 5 millimeter upward from point 0. So use a t-square or just take your rule and then you pick 5 millimeter. You indicate it to the point, and then using your t-square you mark out the point a little. So we'll call this point 0, 1. Also from our diagram, you can see there's also a distance from point 0 downward, which is also 5 millimeter. So measure 5 millimeter downward. So pick 5 millimeter, and then we indicate it to the point. Then using our t-square, we'll mark out the point and we'll call this point over here point 0, 2. So now we've succeeded in getting these 3 points, 1, 2, 3. The next point we're going to get is this. They say 19 millimeter from point 0 to towards our right. So pick 19 millimeter. Pick 19 millimeter, and then we'll mark it to the point, a little point. Just give it a mark. Yes, I will call this point A, which is 19 millimeter from point 0. So the next thing we'll do is that from our diagram, from this radius over here, you can see that they said we should open our radius to 44 millimeter from point 0. 44 millimeter from point 0. This point 0. This here is 0, 2 is 0, 1. So we say 44 millimeter from point 0. So take 44 millimeter from point 0 using our compass. So we've taken 44 millimeter from our rule using our compass. So place it at point 0, which is this point here. You can see point 0, which is 44 millimeter radius. So we draw a semicircle. Draw a semicircle. I'm just making it an outline so that we can see properly. So you can see we've drawn a semicircle. So the next thing is that we want to get this line also, this circle here. They said from point 0 to this portion is 76 millimeter radius. So open our compass to 76 millimeter and we'll place a compass pin at point 02. We've taken 76 millimeter from our rule and then we'll place it at point 02, and then we'll draw a circle. Let me just extend this a little. You can see we've done with that. And then we want to get the next thing we want to do is that I want to get this line. Now there's a line here which you can see going through to this point, and then they said is the thickness of this line is 9 millimeter from this arc, so it's 9 millimeter what equidistance from each other these circles. So we'll just from point 0 here, our radius 44 millimeter, we'll add it with 9 millimeter, which will give us 53 millimeter. So use our compass, open it to 53 millimeter, we'll place it at point 0 at this portion here, and then we'll draw a semicircle. And then also we'll still do the same thing with that from point A. Now we want to get this portion over here, to get this portion. Now from point A, which is 9 millimeter distance to point 0, we'll open our compass to radius 63 millimeter. You can see to radius 63 millimeter. So open to 63 millimeter using our ruler and our compass. So succeeded in picking 63 millimeter. We'll place our compass pin at point A, and then we'll progress. And you can see that it moves exactly from point A towards this portion. Now we've done this, which is 53 millimeter from point A. We're trying to get this portion, so open 63 millimeter radius from point A. You can see it progresses from where this radius 44 stops, and then all through to this point. Let me do it so you can see. You can see it's perfectly done. And so also want to get this portion, this line from this. You can see there's an equidistance line, this the progression of this line. So and we know that this is 9 millimeter, so we're going to add 9 plus 63 millimeter radius. You can see 63 millimeter radius, which will give us 72 millimeter. So open our compass to 72 millimeter using our rule, and I'll place it at point A, and then you see that it progresses. You can see towards this portion. Now you've seen it. So the next thing we'll do is that we'll pick our distance from our vertical line from point 0 upward to be 190 millimeter distance. So we'll measure 190 millimeter with a rule that will mark a point. So pick 190 and then we indicate it the point, which is this. And then using our t-square, we project the point to our left and also to our right. And now we've gotten a straight horizontal line. Now we've succeeded in measuring from point 0 to our point, I'll call this point B. Succeeded in measuring 190 millimeter radius. You can see is from point 0 to point B, which will give us 190 millimeter. So the next thing we need to do from our hanger shaft, our hanger calf and casting, you can see that the top over here is 16 millimeter wide. So we'll pick 16 millimeter using our rule. We succeeded in picking 16 millimeter. Then from where we indicate our points, you can see our points here. We indicate our points, we'll draw a straight line towards our left and also towards our right. So we succeeded in doing that. So the next thing we're going to do from our diagram, we are told that from point 0 to the edge of this portion here is given to us as 158 millimeter. So all what we need to do, we measure 158 millimeter from point B. We'll measure 158 millimeter, then we indicate the point. So we succeeded in picking 158 millimeter towards our right, which is this 158 millimeter towards our right. Then we'll project the points upward. Right. Now you can see the portion over here. We succeeded in getting that. So you can see that there is a curve at the edge of this portion here, which is also indicated by towards our left, which is 6 millimeter radius. So open our compass to 6 millimeter radius. So we succeeded in taking 6 millimeter radius the compass. Now this is an angle 90. So construct a tangential arc at angle 90. All we need to do is place our pin here, scribe an arc at the top and also at the line of our horizontal line over there. Let me erase this portion. It's a mistake, so can erase this. Yes. So now using this point on our vertical line, scribe an arc. Using this portion also on our horizontal line, we'll bisect the arc. Now using the point of their intersection, we'll construct our arc still using what? Radius 6. Draw your arc. So you can see we succeeded in getting this arc. Then you erase this portion a little. You can erase it to dull the edges. Then the next thing you do is that from your diagram, we are told that we should measure 56 millimeter to our left from this portion here. We should measure it 56 millimeter to our left. So pick 56 millimeter. Succeeded in picking 56 millimeter from this portion here towards this portion is 56 millimeter. So what we need to do, we'll just mark it out with a set square, the 56 millimeter. Just give it a little mark so that we can see properly, and then we'll call that point A1. Now having these, that our point A1 is given to us at this very portion here, we have our arc. There's an arc here touching points A1 and also progressing touching what? This our arc here, which is 63 millimeter radius from point A1, which is this here. You can see that there's a radius of 152 millimeter from point A1 touching the radius, that is circumference of this circle here, of 63 millimeter radius. So one of the law of the principle of tangency, when you see an arc, you see circle touching each other, two circles touches each other externally, you add their radius together. Now from our diagram, we've gotten point A, and you see that there is an arc touching point A and also touching the circumference of 63 millimeter radius. So first of all, we want to get this point so that we can know where we can draw our arc. So what we need to do at point A, we place a radius of 153, 152 millimeter radius, which we've already taken with the compass. Then we scribe an arc. You can see we've gotten our arc. Then the next thing we need to do, I told you when cycle touch each other externally, we add. So we add this radius here, 152 millimeter, is touching 63 millimeter radius externally. You can see towards this portion here. So you can see this. So you add 63 millimeter plus 152 millimeter radius, which will give us 215 millimeters radius. It's actually a long radius, very large distance. So you take your rule, your compass cannot, then you extend your pencil, then you pick 100 and what, and 215 millimeter radius. Then you can see that radius 63 millimeter emerges from what, from point A, which is this portion here from point A. So you place your compass pin at point A and then you bisect the arc here, and then we'll call that point X. Now also you open your compass to 152 millimeter and you place it at point X to get this arc. So we succeeded in taking our radius 152 millimeter. We'll place it at point X, and then we'll draw our arc. You can see it's touching our, our circle here, this arc of 63 millimeter radius. You can see, and then progressing it there, you can see it's also touching point A1. So we'll make it an outline. So you can see we've succeeded in getting this arc. Also want to get this, also this point, this uh arc also that is coming here to hit this line. So what we need to do is that we'll, since it's found inside of radius 152 millimeters, so we'll just minus 9 millimeter from 152 millimeter. So when we minus 9 millimeter from 152 millimeter, that will give us 143 millimeter as radius. So place our compass at point X over here, and then well, can see it's touching this. So project, also progress the arc so that it can hit this line. You can see, so succeeded in getting that. So the next thing we're going to do is that we have a radius here of 6 millimeter. There's a curve having a radius 6 millimeter. So all what we need to do is that, don't be confused, we'll just pick our radius to 6 millimeter, a compass to 6 millimeter. So we'll pick 6 millimeter radius. Now there's a curve here of 6 millimeter radius. I want to get that curve on our diagram here. So remember what we're doing here. This is the right procedure. So you just pick from your vertical line, you measure 6 millimeter radius. This 6, you put a point, and then you progress, you project that point towards your right. So you make sure you get it very clearly, very perfectly. And you can see I've projected my point. And then the next thing I'm going to do is that I'm going to look for the portion which, when I bisect this, I can be able to place 6 millimeter radius to get a, a curve here, which is like a full cycle, but just a curve that will be showing. So I'll add 152 millimeter plus and 6, which will give us 158 millimeter. So we've succeeded in picking a 158 millimeter. So place a point at our compass pin at point X, compass pin at point X, and then we'll bisect the arc. Now you can see that we've gotten the intersection as this, at this point there. Let us call that point X1. So we've gotten the point at which we can place our compass radius to radius 6. So we'll pick 6 millimeter radius using our compass. Now I'm placing it at the point of the intersection, point X1, this 6 millimeter radius. Then we'll draw our arc over here, touching this. You can see it's touching this perfectly. So that your work will not look dirty, you can erase this portion a little, so that when progressing your arc will be neat and nice. So from here, from our point X1, we'll draw our arc. Now you see, this is it. You can see perfectly the arc. Now let me show you something over here. Let me put this construction line. Now you can see that there's a perfect cycle touching these two portions together. Now whenever you use any method, people get it wrong. They use some method, and then just know that whenever you're using this, your cycle must touch this and this, and it must be a perfect cycle, because they just erase that portion. So or let me just leave it for more clarity purpose, so that you can understand it better. So we'll outline this portion that needs to be outlined perfectly. Now you can see we've outlined this. In the diagram, your cycle is not showing, it's just an arc that will be showing. Then the next thing we're going to do is that, now we know that this is 158 millimeter towards our left, that we got to this point. Now I want to know where we get this point from. So what we need to do is just, this is the total distance of the base of the top, the apex of the hanger. So you see 320 minus 158 millimeter to get this portion from point 0 to this portion here, which will give us 162 millimeter. When we minus 320 millimeter minus 158 millimeter, that will give you 162 millimeters radius. So from point 0, from point B here, sorry, point B, this is B or 0. So from point B, we're going to measure 162 millimeter towards our left. So we succeeded in getting that. This is the portion here. So project it downward to hit the down line. You can see we're having this, and also we have a curve there which is 6 millimeter radius. So we'll do same thing over here. Now when this method only works it at when you are to construct a tangent arc on angle 90 degree. Some people get it wrong, and then they use every other curve, use this method for every other curve, which is wrong. So pick 6 millimeter radius. So this is like an angle 90 degree. So we place it at this point, cut an arc on the vertical line, and then also on the horizontal. Then using the points on the horizontal, you describe an arc, and using the point on the vertical here, you bisect the arc. Now at the point of the intersection, you draw your arc. So we've gotten the curve. The next thing we'll do from our diagram, you can see the social measure 54 millimeter radius from our point here where we got our straight horizontal line. Measure 54 millimeter towards our right. Then indicate to the point. I will mark that point over there. Mark the point so that we can see visible point. So now we'll call this point here point A2. Now we've succeeded in getting point A2. So from our diagram here, you can see that point from point A2, there's a radius of 102 millimeter touching point A2. This is point A2, touching point A2, and also touching a radius of 108 millimeter from point A, which is this. Remember, we got this arc here, this semicircle, using radius 76 from point 02. Now, this arc here, there's also another circle here, which is 76 millimeter radius from point 01. So we'll open our compass to 76 millimeter radius. We'll place it at point 01, and then we'll draw our arc. Now you see that 76 progresses from where 86 progresses from where 76 stopped. You can see. Now this portion here is no longer needed from the diagram. So you can see each circle we're touching each other in the diagram. So we'll erase this portion. Now we've gotten this portion perfectly. And the next thing we're going to do is that we'll open our radius to 108 millimeter. 108 millimeter. Then we'll place it at point A. This is 108 millimeter at point A. Bring it here. Then scribe an arc. Now you can see that this portion here need an arc. A radius that will touch will cut this portion together. So what we need to do is that we'll measure 12 millimeter downward using our rule. We measure 12 millimeter downward. This is 12 millimeter. Then you project the point of 12 millimeter downward towards this portion. You can see. So you are free to erase what is inside. Erase this portion inside. So we're having a tip of a straight line and also a circumference of a circle. That there's a circle here touching this portion what externally to have a curve. So what we need to do is that we'll measure 186 millimeter. We'll add it with 6 millimeter radius. So say 186 plus 6 millimeter. So we've succeeded in adding 86 millimeter plus 6 millimeter radius, which is this curve, which will give us 92 millimeter as radius. Place our compass pin at point 01. Scribe an arc. Now from the tip of our circle here, you can see there's a tip here. We'll open our compass to radius 6. Open our compass to radius 6. So we've taken radius 6, place it at the tip of this circle here. Then we'll bisect this arc. Now using same radius 6 at the point of its intersection, you join using point of intersection using the same 6 mm radius which we've gotten over here. So you are free to what, to erase this to make your diagram look more neater, look more neat, sorry. So we've gotten this. So the next step we need to do is that we need to get this, there's a radius touching point A2 and touching the circumference of 108 millimeter radius. So open our compass to 102 millimeters radius. Open our compass to 102 millimeter as radius. So place it at point A, or scribe an arc over here. You can see my arc. So now the next thing, I want to bisect this arc so that we can get the the circle touching this portion here. So we'll add 108 millimeter plus 102 millimeter radius, which will give us 110 millimeter, which will give us 210 millimeter, sorry. So got 210. This is 108 millimeter starting from point A here. Now touching this arc also of 102 millimeter. So when you join, you add 108 millimeter radius plus 102 millimeter. That will give us 210 millimeter. So pick 210 using our compass. Place our compass pin at point A here. Then we'll bisect the arc. Now using the point of their intersection here, I'll call the point of their intersection point Y. Now using point Y as a point of the intersection, we'll open our compass to radius 102 millimeter. Now we've succeeded in opening a compass to 102 millimeter. So using the point Y as a point of the intersection, we'll draw an arc starting from here, hitting point 2, point A2. So we're free to erase this portion of our hanger casting. And then from our diagram, you can see this arc here, which is 140 millimeter radius. Now from point Y, which is this, which is also this point here, this point is called point Y, which is here on our diagram. So we'll pick 140 millimeter radius, place it at point Y, and then describe an arc, which is this. Now also we'll take, you can see this arc over here, which is this, is given to us as 112 millimeter. So we'll measure 112 millimeter, pick 112 millimeter using our compass and our rule. 112 millimeters radius, 112. So 112 millimeter. Place it at point X. A compass pin at point X. And then we'll construct an arc. Now you see, we can now erase this portion. Now you can see that our diagram is coming out gradually. So we've gotten this. So we should place a circle over here, which radius is radius of 12 millimeter. So we're going to create a cycle so that we'll have this curve which is 12 millimeter radius at this three portion. So all what we need to do is that we'll measure 12 millimeter from this point here, call this point B1. We'll measure 12 millimeter from point B1 here. So pick 12 millimeter is 10, 11, 12, and then we'll draw a straight line, construction line here. And you see what we are doing. This is the right method to use so I can get your perfect circle there. So the next thing we need to do is that if you watch from point X here, you discover that there's a radius of 112 millimeter radius here. So when the cycle touches each other internally, we are going to minus. So we minus 12 millimeter from 112 millimeter. We minus this 12 millimeter from this so that we can get the midpoint, the arc at which you can get this circle. So say 112 minus 12 millimeter, that will give us 100 millimeter radius. So pick 100 millimeter with our rule, 100 millimeter with our rule. Then we'll place it at point X. We'll place it at point X, and then we'll bisect the arc. Now at the point of the intersection, we'll open our compass to 12 millimeter radius. Open our compass to 12 millimeter as radius. And then you open your compass pin to 12 millimeter radius. Place your compass pin at the point of the intersection, and then you can draw your arc. And to show you that this is the right process, let me just make the cycle complete with the construction line. You can see this. Now you can see that this is a construction line and this is the cycle. So you erase this portion to your rule just to make the tip door. So you repeat the same procedure here. So we'll want to get the same cycle here. So all what we need to do is that we'll add 140 millimeter radius plus 12 millimeter radius, which will give us 152 millimeter. So pick a compass to 152 millimeter, place it at point Y here, which is also this portion at a diagram. So at point Y, we'll bisect our line. Then we'll open our compass to 8 millimeter radius. So succeeded in taking 12 millimeters radius. This is 12, 12. So place it at the point of the intersection, and then we'll draw an arc. And then so that you can see properly, then you push this as a construction line. You can see. So I've done getting the curve, so we can erase this portion. So we'll do the last step, which is this. Now this is another method entirely we're going to be using when cycle touch each other externally and also internally at this portion. Now from this, the cycle here is touching this arc here what externally, so we're going to add 140 millimeter radius plus 12 millimeter radius, which will give us 152 millimeter. So pick 152 millimeter at a compass, place it at point Y, and then we'll scribe an arc. Now you see we'll scribe an arc. So the next thing we're going to do is that this arc here, the cycle is touching it what external internally. You can see when the cycle is here, this is what I mean. Now at this portion here is touching this externally, while at this portion here is touching what internally. So when cycle touch each other internally, we subtract. So subtract 12 millimeter radius from 112 millimeter, which will give us 100 millimeter. So open a compass to 100 millimeter radius. So succeeded in opening a compass to 100 millimeter after we subtracted 12 from 112 millimeter radius. So place a compass pin at point X, which is this. So a compass pin at point X, then we'll bisect the arc. Now using the point of the intersection, we'll open our compass to radius 12 millimeter. So we've opened to 12 millimeter radius, we'll place it to the point of the intersection, and then we'll draw our arc first. You can see our arc is touching, and then we are free to draw a circle lightly. You can see. So we can erase this portion here, which is this, and then we are free to outline the top with our pencil. So outline, you can see we've outlined neatly, but we're not done yet because we have this top. So they say we should measure. Now from our diagram, they say we should measure 65 millimeter radius from this edge, 65 millimeter radius. So we're picking 65 millimeters radius. So this is 65 millimeter. Then we'll indicate it to the point, and then we'll project the point downward. Project the points downward. So this is it here, and also measure 63 and 65 millimeter also from the edge of this, and then we'll indicate it to the point. Then we'll project that point downward also. Then from our projected line, the stone should measure 3 millimeter. So measure 3 millimeter radius. Indicate the point over here, and then we'll project this with an out. Just project it to hit this line also. Then the next thing we'll do is that we have a radius here of 3 millimeter radius, which is here and here. The curve 3 millimeter radius. So pick 3 millimeter radius with our compass. 3 millimeter radius with our compass, and we'll repeat this already 3. So scribe 3 here. Using this portion, scribe an arc. Using this portion, we'll bisect the arc, and then at the point of the intersection, we'll draw a curve. Now repeat same procedure. This is 3 mm already, so we are repeating same procedure we did. Now the point of the intersection, we'll construct our arc. You see, we're done with that. Then we'll outline. We're outlining. So outline this portion also. And then that is it. So we can erase this portion to bring out the objects more clearly. So we're done with the top portion. So the next thing we'll do is that we'll focus on this portion next. Now from point 0, we'll measure 12 mm upward. 12 mm upward. Then we'll draw a straight line, cutting each of these as circles arc. This portion, so we're free to erase this. And then we'll measure another 12 mm downward. Indicate the point, and then we'll project the point towards here. Why this is for this. Now if you check, here is 24 mm, so 12 up, 12 down, giving us a total diameter of what? 24 mm. So now they say that each of these will have a circle of a radius of 33 mm radius. So, and here also we have a radius of 6, 6. And then for us to get the total distance of this portion here, so we should measure 80 mm from our vertical line. So let me just use this as my reference line. Okay, I have a reference line already there, so I'll just measure 80 mm from point 0 to my right. 80 mm. So I'll measure 80 mm, which is this. Then I'll project my line upward, and then I'm free to erase the extension path. Then you can see over there. Now we're having a curve here of 6, okay, of 3 mm radius. This is 3, this is 3, this is 3. So open our compass to 3 mm radius. Now since this portion here is an angle 90, we'll just place our compass pin at this point, scribe an arc. Do same here. Using this portion, we'll bisect, scribe this arc, and then using this, we'll bisect the arc. Now using the point of the intersection still on 3 mm as radius, then we'll draw this. Which if you want, you can do this, but because of we're having all of that portion, all of that curve to do as well, so we'll leave that where it is. So the next thing is that we want to get this curve here, 3 mm curve at this point, at this, and at this point. So all what we need to do is that we'll still use the same procedure which we did here for this, since this is the apex of the top of this, and we'll have a radius of 3 mm. So we'll measure 3 mm radius, and then this is it. That will extend this portion with a construction line passing all through. Now at this portion here, we need a curve here, but we need the arc, the midpoint of this. So all what we need to do is that this circle here is 76 mm radius. We have also 3 mm, so we have to minus 76 minus 3, which will give us 73 mm as radius. So pick 73 mm as radius, 73 mm as radius. Placing our point at 0.02, our compass pin at 0.02, we'll bisect the line here, and then we'll open our compass to 3 mm radius. So place our 3 mm radius at the point of the intersection here, and then we'll draw arc. Now you can see we have the curve, but so that you know that it is the perfect method, you can just make this here, but these are curve. So these are curve, these are curve. So the next thing we'll do is that we'll repeat same process here. Now this arc coming over here, we'll check. This is 44 mm for this, so we're having 3 here, so 44. Since it's we're touching it externally, we add 44 plus 3, which will give us 47 mm. So pick 47 mm using our compass. All right, now we've taken our 47 mm. This is what I mean. This is a radius 44 mm at this point here. Now we have a 3 mm radius here, you can see, and this is touching this arc here, what externally. When circle touches each other externally, what you add, so add 3 mm radius plus 44 mm radius, which will give us 47 mm as radius. Our compass pin at 0.0 will bisect this arc here, and then we'll open our compass to 3 mm radius. So still in taking 3 mm radius, using the point of the intersection, we would draw our arc. For more, okay, we'll just draw our arc because we still have another curve over there. So this is the arc. So we're free to erase this portion, and then the last curve is at this portion. So we can recall that this was 44, but when we added 9, it gave us 50. That will give us 53 mm radius. You can recall this was 44 mm, but the distance between here to here is 9 millimeter, which we got this over here. So we need a curve that will come over here. So we'll add 50. We have 44 plus 9 mm, it will give us 53 mm. Since this is touching this portion here externally, we also add 3 mm to the 53 mm, which will give us 56 millimeter radius. So pick 56 millimeter radius from our rule. So we succeeded in taking our 56 millimeter, place it at point 0, and then bisect our line here, and then we'll open our compass to compass 3 millimeter radius. Now using the point of the intersection, we've taken 3 millimeter radius. We'll draw our arc. Then we're free to erase this extension, the sharp part of it. Then if you like, it's your choice, you can just put this over there. So the next thing we'll do, we're going to outline the top to make it look neat. So we'll succeed in outlining the top. So also here at this portion, we'll have a curve of 6 millimeter radius. So all I need to do is that since it's touching this curve here, there's a cycle here with a radius 6 millimeter. It's touching this cycle externally, so I'll add 6 plus 76, which will give me 82 millimeter. If you watch this, is 76 millimeter touching this small cycle here of radius 6 millimeter externally. So we added it, which gave us 82 millimeter. So place a compass pin at point 02. Prescribe an arc. Now open our compass to radius 6 millimeter. We succeeded in measuring 6 millimeter. So place it at this point here, and then we'll bisect our arc at the point of the intersection using the same 6 millimeter radius. Using 6 millimeters radius, we'll construct our arc. Using 6 millimeter radius, we'll construct our arc, and then this is it. But if you choose to, you can put this just for to show that it's correct, and then we'll outline this portion over here, and then through this portion of the diagram. Then we're left with the last process, which is this here. Let's say from point 0 we should measure 86 millimeter downward. So pick 86 millimeter, and then we indicate it to the points. Then we're free to draw a construction line. Now they say the total diameter of this is given to us as 24 millimeter radius. So we do the same thing. We pick 12 millimeter to our left, indicate to the points, pick another 12 millimeter to our right, indicate with the point. Draw a straight line, project the line upward. Now using radius 6, we have to find a curve this way and this way, which we've done, which is the same process as this, and this. All what you need to do is that at this portion here is 76, so you add 6 millimeter plus 76, you scribe an arc here, and use 6 millimeter, you bisect. Okay, let me run it. So I said from this portion here, this is 76 millimeter. So I say 76 millimeter plus 6, which will give me 82 millimeters radius. So I'll pick 82 millimeter with my compass using my rule. 82 millimeters radius. And then I'll place it at 0.02. You can see 0.02, and then I'll scribe an arc. I'll open my compass to radius 6 millimeter. And then I'll place it at the tip over here, and then I'll bisect my arc using the point of the intersection using 6 millimeter radius. Then I'll draw my arc. You can see I've drawn my arc over there. Similarly, I'll do same stuff to this portion. You can see at this portion here is still on 76 before it leaves, so it's still on 76. You can see my former arc, a little of it, it's not 76. So taking 6 millimeter radius here, I think this is 6 millimeter radius. I scribe my arc here, and then taking 82 millimeters radius, 82 millimeter radius, placing it at 0.02, which is this. I'll scribe the arc, you can see, and then I'll open my compass back to 6 millimeters radius. I've picked my 6 millimeter radius, so this is now the point of the intersection. I'll draw my arc. You can see I'm done with that. But if you want to see clear purpose clearly, you can just do this and this like this. So I'm done with this. I can erase this portion a little, and then I'll outline the base. And I'm done constructing my shaft hanger casting using the principle of tangency. Remember to give me a thumbs up and then subscribe to my channel. You can watch the video over and over and over again for more clarity purpose. Thank you, and do have a blessed day ahead. Don't forget to share, like, and subscribe. Thank you.